Hi, I'm Mr. Kangas, and today we're going to take a look at Chapter 10, Section 3, Dilations. Basically what a dilation is taking a shape and increasing or decreasing its size. So we may decide we want to take this triangle and make it twice as big as what it currently is, or we may want to make it a third of the size that it currently is. And so a dilation is just simply how do you do that if you have a shape that's on a coordinate plane. So the first thing you need to do in order to figure out a dilation is you need to know what are the ordered pairs of your your vertices. So I took my original triangle here and I wrote out the ordered pairs. I have an ordered pair of positive 2, 1, positive 3, 3, and positive 5, 1. Remember, x coordinates are on the left and y coordinates are on the right. So after that, there are two things you need to understand. When I am increasing or decreasing my size, I'm actually increasing or decreasing it by what's called a scale factor. When I say I want to make this triangle 3 times as big, that 3 times as big is my scale factor. So that scale factor would be represented as a 3-to-1 ratio. My original triangle, for every 1 inch, 1 centimeter, 1 unit on my original triangle, I want 3 units on my new one. I want every aspect of my new triangle to be 3 times as big, 3 times as long, 3 times as wide. So if I want to do the vice versa of that, and I want to make my triangle smaller, okay, then I'm going to have a 1-to-3 ratio. Okay, or in other words, I'm going to make it a third of the size, because if we write a 1-to-3 ratio as a fraction, it's 1/3. So I'm going to make this triangle a third of its current size. So that's the first thing to understand, is what a scale factor is. And if you want to make something twice as big, 3 times as big, half as big, a third as big, all you have to do is multiply. So for example, over here I have listed the ordered pairs, or the vertices, of my current triangle, and if I wanted to implement a scale factor of 2-to-1, or in other words, I wanted to make this triangle twice as big as it currently is, I would take every single coordinate of every single vertice of this shape and multiply it by 2, because if I want to make something twice as big, what do? You multiply it by 2. If I wanted to make it 3 times as big, I'd multiply all of these by 3. Same concept applies with getting smaller. If I wanted to implement a 1-to-3 ratio, or in other words, make something 1/3 of its current size, instead of multiplying by 2 or 3 or 5, I would multiply every one of these coordinates by 1/3. If I wanted to make something 2/3 as big, or in other words have a 2-to-3 ratio or scale factor, I would multiply every coordinate by 2/3. And yes, that does get messy, because yes, you are multiplying with fractions and a lot of people don't like that. But that's just the way it is. That's what you have to do. If you multiply any number in the world by a fraction, so if I multiply a number by 2/3, what that ends up doing is getting you 2/3 of the number you're multiplying it by. It gets you 1/3 of the number you're multiplying by, or 1/2. When you multiply by a fraction like 1/2, you get 1/2 of the number you're multiplying by. If you multiply by a fraction of 1/3, you get 1/3 of the number you're multiplying by. Just like if you multiply by 2, you're getting twice as much as that number. If you multiply by 3, you're getting 3 times as much of that number. So that's kind of how that works. So I'm going to make a dilation here. In other words, in this case, I'm going to increase the size of my triangle, and I'm going to increase it so that it is twice as big. I'm going to have a 2-to-1 scale factor. So I'm going to multiply every coordinate by 2. And this is what I got for my new coordinates. Now, the second thing you need to understand, the first thing we just went over was scale factor. And I think that's a concept all of us are capable of getting. The second thing is we need to understand center of dilation. Basically, the center of dilation is going to be the new origin of your coordinate plane that you're going to map these points from. A lot of times when you're doing worksheets or you're working on something, they will say dilate this triangle with a scale factor of 2 to 1 around the center of dilation at the origin. So they'll just have you use the origin as your center of dilation. I am not going to use the origin as my center of dilation because I don't want to clutter this area of my board. I want you to be able to clearly see what I'm doing. If I use the origin, I'm going to have my new points for my new triangle are going to be over here, and so my little triangle will be inside my big triangle and things will start to get cluttered, and I don't want that to happen. So all I'm doing is I'm picking a new center for dilation, and that new center is going to be back 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going back 10, up 2. So they might say that they might say that you have a new center of dilation of -10, +2. That's my center for dilation. So what I'm going to do now is I'm going to map my new coordinate points using this center of dilation as my new origin. So I'm going to start here, and if my ordered pair is 6, 6, that means I'm going to move right 6, up 6. So I'm going to start here, pretend it's like my origin, and I'm going to map my first point for my new triangle that is twice as big. So I'm going to go over 1, 2, 3, 4, 5, 6 spaces, and I'm going to go up 1, 2, 3, 4, 5, 6 spaces. There is my first point. And if you see here, the original point was 3, 3. So this point here, my new point is 6, 6. So this point actually represents the top of my triangle. So now I'm going to plot the second point. The second point is going from a 2, 1 to a 4, 2. So if I did everything correctly, my second point, as you can see, 2, 1 is the bottom left corner of my triangle. So this second point should end up kind of down and to the left of my first point I plotted. So we're going to go over 4, up 2. 1, 2, 3, 4, up 1, 2. And as you can see, we are down and to the left. Last point, we had a 5, 1 originally. Now we have a 10, 2. So we're going to go over 10. And we're going to go up 2. So we're going to go over 10, up 2. Oh, and I'm actually going to backtrack here to this middle point that I graphed. I did go over 4 right here, but I forgot to go up 2. I was supposed to go over 1, 2, 3, 4, and then I needed to go up 1, 2. So this would actually be the bottom left point that was here. I only went over 4 and never went up 2 like the ordered pair says. So just to recap real quickly, I wanted to create a new triangle that was twice as big as my original one. Okay. And so I wanted to dilate it by a scale factor of 2 to 1. So I took all of the ordered pairs of every vertice and I multiplied every coordinate by 2. Okay. Now if I wanted to make this 3 times as big, I would have multiplied every ordered pair, every coordinate by 3. If I wanted to make it 1/2 the size, I would have cut every one of these ordered pairs in half. And then after that, I had to find my center of dilation, which oftentimes they'll say is just the origin. This time I moved the center of dilation way over here to -10, 2, so that our two triangles would not collide on top of each other and clutter my board. So this was my new origin, so to speak, and I took my new points and graphed them. The first point was over 6, up 6, so I went over 6, up 6. Next point was over 4, up 2, so I went over 4, up 2. And the last point was over 10, up 2, so I went over 10, up 2. I had 3 new points, I connected the dots, I created a dilated triangle of my original that is now twice as big as the original. So that's really all there is to dilation. Like I said, if we change the scale factor to something like 1/2 or 1/3 or 2/3 or 3/2, we're just going to multiply by that fraction. So if I wanted to make this a 3 to 2 scale factor, I would multiply every coordinate here by the fraction 3 over 2. and those would make up my new points. And yes, that would get messy, and I'd have decimals and fractions and things like that, and it would make the process a little bit more of a headache. But we should know how to work with fractions at this point in the year. So if there are any questions, let me know. Please make sure you took notes. Dilations are probably the trickiest thing to do in this section. So if you have any questions, let me know. If you're having trouble with your notes or something I said in the video, again, let me know. The next video will be on Chapter 10, Section 4.